Hi, everyone. Thanks for joining us. We'll start the Atomic Red Team webinar in a couple of minutes while we let everyone get logged in. FYI, attendees are in listen-only mode. All right, let's get started. Hello, thanks for joining Red Canary and welcome to today's webinar with Atomic Red Team. My name is Kia and I'll be your moderator. Before we get started, here's a few housekeeping items. As a reminder, all attendees will be in listen-only mode. We will have Q&A after the presentation. Feel free to post in the GoToWebinar questions pane. If you are having any issues with audio or connecting, please go to GoToWebinar support. Lastly, we will be sending links of the recording and all related resources to all attendees. With that, I'll hand it over to Casey Smith.
Great. Thanks everybody for joining us today. Super excited about the content we've got to go over. We're going to be talking about testing with Atomic Red Team on Mac OS and Linux. So a couple of things to get started. We've got a couple things here, recognizing obviously it's May the 4th. We'll be sprinkling Star Wars things in here throughout this day. But anyway, the idea here is we've been talking about Atomic Red Team and it's really been focused on Windows. And we want to make sure we address other organizations that have deployed Mac OS or Linux and how do you collect and analyze the telemetry on those systems. So we've got a couple of us here today. Again, my name is Casey Smith. I'm in the applied research team here at Red Canary. We've got Mike Haig, and also Adam is our guest speaker with us today talking about Mac OS and some Linux testing. So, all right. As Gandalf said, use the Force, Harry. Great quote for this, for today. So anyway, good times. All right, so jumping right in, we're gonna do a really brief overview of Atomic Recap. If you haven't heard of Atomic Red Team before, we'll have resources at the end that you can go to see where to get our code or get information about Atomic, but I just want to make sure everybody's on the same page that understands what Atomic is, the origin, and how we use it. Then we'll dive right into some Mac and Linux testing, and we also have some demos that we'll show as we go through the slides. Hopefully this is what you're here for. Feel free as you have questions along the way. While we may not stop, if you drop those questions in the chat pane, Kia can queue those up and we can get those ready for us later on. So we all know about testing, and one of the big problems is you deploy a lot of different applications or security solutions on your network, but the question is always, how do you know that it's actually working? And then the question is, people are like, well, how you just test it? And the question or the problem we wanted to answer with Atomic is, how do you actually do that? So what are the test cases? How do I actually know that the telemetry is being generated to help me detect and evict adversaries off my network? So we'll be talking about that today and how we can actually do that using the Atomic Red Team. The idea behind Atomic Red Team, just a real quick overview. Again, there's more resources. We've done a couple other webinars on this. It's an open source framework. We would love feedback. We realize we have some gaps in Mac and Linux, so we'd love to have people contribute that are participating today. Think of these as discrete unit tests. That's really where the term Atomic comes from, is that smallest unit that we can actually test. And they are mapped back to the MITRE attack framework. So if you have a particular technique on the grid that you want to look at or the matrix, you can go to that and then find that test case and run it in your organization. So that's really the heart of the Atomic Red Team, why we created it. And there's a lot of attention on Atomic Red Team right now, or really MITRE attack in general. So we want to make sure you know about some of the other projects we'll talk about later on. We really encourage you to find a project that works for your organization and can help you do the testing you need. With Atomic Red Team, we have really one of our principles was small, low overhead to get up and running. So we have sort of that small security shop that does not really sure where to start. this is a great place to start, and then you can step into some of the other projects that may do things more automated or other techniques that you may want to cover. Okay, so one of the things that we want to get into before we start talking about testing Mac OS and Linux is address the concept of how are you actually collecting telemetry for these operating systems, and what are you then using to do the analysis? So I'm going to kind of open that question up to Mike and Adam to give us some feedback on what you see organizations doing that helps them get visibility into these operating systems.
Yeah, so thanks, Casey. So collecting telemetry, like, so how do you collect the, what's going on in your system? And for some systems like Windows, it's really kind of, they've made it easier for you just to use, system logging. There's plenty of tools. But when you get into macOS and Linux, it's a little bit more difficult. Mac specifically makes it really hard to get auditing information off of the system, in a nice, easy way. So we have to use other utilities. So of course, we use Carbon Black a lot here, CrowdStrike, Falcon, but there's a lot of open source and free utilities as well. And on the Linux side, there's even more built-in capabilities for auditing as well, which we'll kind of get in on the next slide.
Cool. I guess I'll go ahead and jump to the next slide because I think it maybe answers that first question about what are some of the tools. I'll let you and Mike speak to how you see people using these utilities.
Right. Yeah. So, as I mentioned, there's some good free projects out there. So Facebook has come up with OS Query, which is actually multi-platform. So you can get OS Query on Windows, Mac, Linux, in a lot of different flavors. It's a great tool. It's a really cool way to kind of ask questions of your endpoints. So most of the way that you interact with OS Query endpoints is through like a SQL-like command. So you can ask questions like, where are the processes on, which processes are running on this system? And you can kind of schedule those and queue those up in configuration files, which is really neat. Super Audit is one that's a little bit newer to me, but it's really neat for the Mac side. It's from Jonathan Levin and the fine folks over at Technology Geeks. They've come up with this really neat auditing tool that you can deploy in your environment and get really nice stuff right off of the audit pipe on Mac systems, and in a couple of different formats, and we'll show you some examples of those later. In Linux, of course, OS Query is still an option, still a great option, and you can really tune Audit D, just the default auditing subsystem. You can really tune that nicely using either some resources you find online. You can go and get the CIS benchmark for your platform of choice, and you can get that churning out some good information for you.
Awesome.
Is there?
I don't know that we have. Go ahead.
Oh, yep. I was just going to ask, is there good ways outside of like OS Query, Super Audit? Is there some other ways to ship that data off, like through like syslog or something like that?
Yeah, so it's a great question. So on the Linux side, syslog is very easy. On the Mac side, you can certainly use something like a Splunk universal forwarder if you're using that ecosystem. You can get into playing with different other logging projects that just package log files up and ship them off the system. Because of course that's what we want to do. We want to get log files off of the system as soon as possible, because as a general rule, you don't want to trust a host that could potentially be compromised. So the quicker we can get audit information off of a host, the better.
Cool. Awesome. Yeah. So again, with the atomic testing, these would be the things that you would be seeding the telemetry into. And then for detections, I guess I'll go ahead and jump to the next slide. These are some things that tools that I'll let you guys speak to that you've seen out in the industry around actually taking that telemetry and then doing analysis. So.
Yeah, so
yep.
Obviously some of the bigger ones here, yeah, thanks, is you use Splunk to perform that analysis. Splunk has a lot of TAs for Linux, Mac, and there's the OS Query app out there. And then there's your standard McAfee or Nitro, McAfee ESM, whatever the new name is for it today. ArcSight, Mac Linux, you use grep, sedoc. There's obviously Elastic, Logstash, and Kibana. You can use Elk Stack on it for all the analysis. And then probably one of the more newer interesting ones for analyzing the OS Query data would be your Collide which is really awesome as well. Got anything else there, Adam?
No, that's good. Yeah, Collide is kind of OS query specific, and it's a good way to orchestrate a lot of those agents. So they have Collide Fleet, and they have another product that's not coming to mind, but it's something that's good for updating OS query agents. So Collide's got they're very OS query focused, but if you find value in that tool, it's a great way to kind of orchestrate across your entire environment.
Does Collide let you task the fleet with a query, or is it more analyzing what's already been collected? Kind of both, or?
Yeah, you use both. Yeah, they have different projects that will allow you to kind of do both of those things.
Okay, cool.
I think one of the features in it is you're also able to batch out all of your jobs over time and whatnot. I think that's one of the more powerful pieces to Collide.
Cool. So I think Adam had some feedback on like how to use some of the atomic life cycle. So I'll let you kind of speak to this one, Adam, about like just the cycle you go through with the testing of atomic and collecting the data.
Yeah, absolutely. Yeah, so this is kind of a high level overview of how you go from testing, whether it be with atomic or really anything, but atomic specific to this talk, how you go from atomic testing through the detection lifecycle. So we start at the top, we're testing a permutation of a technique, trying some other way to invoke the technique, trying some other tool, some obfuscation. And then you see, do you have anything that detected this? Do you have any kind of detection capability, some kind of alert that's firing off and telling you, hey, I saw this thing that you ran? Because that's the desired end state, right? So if you caught it, that's great. Now go back and you can test that same technique in a different way. You can look at it, like I said, with other invocations, different syntax. Make sure that you have really resilient detection capabilities. So if you didn't detect it, if you didn't have any warnings that went off, then you have some work to do. You go back to your source of record, you look and say, okay, do I have any telemetry, that shows me this thing happening? Any raw data anywhere across my environment? And if I do, then I can operationalize that. Then I can take that data and I can build that out into a detection capability. And again, like I mentioned before, you want to make sure that you're building resilient detection capabilities, which means I want something that's going to cast the widest possible net to catch the most evil without crushing me with false positives. So instead of writing a detection that's specific to the command line you run, maybe you want to broaden that a little bit. You want to remove some of the specificity to your detection capability so that you can catch more things that adversaries might do in your environment. And of course, that goes back to testing as well. So once you build something, you want to make sure that it works, and you want to continue to test that detection capability. If you don't have anything, if you don't have the raw data, then that's a completely different problem. But hopefully with the slides that we went over before, there's some tooling in there that you can grab that won't cost you anything but your time to deploy on a test system and figure out how you can get that data into your, whether it be your SIM or your log aggregation infrastructure, somewhere where you can see that data and you can write detection capabilities that will key off of it. And of course, all the arrows go back to testing. So just keep testing. You're always making progress as long as you're testing and making sure that you're finding these techniques.
Awesome, good stuff there. All right, so with that's kind of an introduction to some of the tools you can use. Again, it doesn't make sense to do your testing, like Adam's saying, if you're not collecting the telemetry. So we want to focus now on some techniques that are specific to Mac OS and Linux. Coming from a Windows background for me, I think it's helpful to keep in mind that attackers have similar objectives or similar life cycle they have to go through, just on a different operating system. So some of the same techniques that you may see in a Windows environment may manifest themselves differently in Mac OS and Linux. But Adam and Mike have put together some good demos, again, mapped back to the MITRE taxonomy or MITRE matrix, the attack matrix that describes these attacks. So with that, we'll go ahead and jump right into some actual OS X tradecraft or Mac OS tradecraft. So I'll let you talk to this one, Adam.
All right, cool. Thank you, Casey. And just to kind of before I jump into this one, just to kind of piggyback on what Casey said, Windows gets a lot of the love, a lot of the research time, a lot of the tooling, of course, because it has the market share. But if you think about a lot of the organizations that I've worked with, the places that I see little pockets of Mac OS, see some Linux systems, those are typically either executive machines, developer machines, Linux servers that are critical infrastructure running critical applications. And just because you only have a couple of them doesn't mean that they're not critical in your environment. A lot of times the people that are using those have, enormous access to other areas in your organization. So you really owe it to yourself to test those things and understand kind of the tradecraft that's used against those systems. So now I'll step off my soapbox and we can talk about AppleScript. AppleScript is a really cool built-in scripting language on macOS. And it can do lots of things like execute programs. It can talk to programs, so you can make applications. You can click buttons with it, make applications like accept your input. You can talk to open SSH sessions. There's really a lot that you can do with AppleScript. So you can almost think of it like a PowerShell kind of equivalent, maybe not as powerful, not as many widgets that you can bolt into it, but without elevated privileges, even you can do just a lot of evil on systems with AppleScript and some light trolling as well, which we'll get into in a little bit. But it's a really neat technique. This is kind of the blurb from MITRE. Just if you haven't spent any time in ATT&CK, you can kind of see the flow, so you can get the context of what the thing is, what the technique is, ways to mitigate it, and ways to detect it. So different ways that you can kind of pick up on that with the telemetry data that you have.
Cool. Yeah, so you mentioned PowerShell, and there's like PowerShell logging and things like that. Are there things like that in AppleScript? Like, is there a way to get like transcript logging for AppleScript, or ways to lock that down? Or
yeah, so a lot of the ways that you execute AppleScript on the command line invocation is this OSA script, and you can absolutely grab the command line of that. And a lot of times it's very telling exactly what it's doing. So yes, there's definitely ways that you can kind of pick up on that. Native logging is a little bit tougher on Apple in general, but you can definitely pick up the telemetry of the execution of these scripts. Cool. And just to kind of talk a little bit more about mitigation, you can set AppleScript to only execute scripts that are signed by a trusted developer, which makes it a little bit easier. So somebody can't just come in there and run scripts willy-nilly in your environment. There's not really a way to completely disable AppleScript that I've found. I'm sure you could probably trash the binaries in some way, but there's a lot of software on this developer Mac that actually depends on AppleScript being there so that they can do the things that they do. So cool. It's a little safer just to lock it down to trusted developers.
Gotcha. Awesome. So this is T1155. I'll let you kind of talk to this one too.
Yeah. So this is kind of one of the tests for in Atomic for AppleScript. Specifically, we borrowed this from the Empire project. So Empire has some fun launchers to get that initial shell on Mac systems. And one of them is using AppleScript. And so if you look at the command line, and the whole command line is really nice and unwieldy because it gets to like encoded Python a little bit later on. But you can see OSA script saying do shell script, which does exactly what you think it does. So it runs a shell script. And then what's happening is there's a long Python command that's being echoed into Bash and then echoed into Python. So it's really neat from a telemetry perspective to kind of see how that runs. Of course, this being this being out there on the GitHub, we've kind of removed all of the nasty bits of the launcher, so it just goes to localhost. But it's just one way to do it. You can absolutely take this as like a frame, like a starting point, and then add some different code in there and see what kind of fun you can come up with.
Gotcha.
Hey Adam, how noisy is AppleScript just like natively on a Mac?
It's a good question. It's not terribly noisy. So it's not something that a lot of people, at least from the environments that I'm familiar with, that I've worked in, not a lot of regular users or even sometimes power users are using it because power users are usually going to be using something like Bash scripts or Python to do their tooling work. But what you will see is a lot of applications developed for macOS that use AppleScript just to run their normal day-to-day business. Sometimes you'll see it as part of installers, where it will pass some variables or it will call some applications to pop up during the install. So not terribly noisy. And in fact, that one of the things I would definitely recommend is just look and see how many times OSAScript is executed in your environment.
Right.
You'd probably be able to tell very quickly which ones are legitimate, and exclude those particular applications.
And maybe
definitely.
looking at the parent relationships and things like that. If you can get that makes sense. Okay, cool, awesome. So yeah, so that's an example of from our Atomic repo. You can pull that down and customize these if you want to do something additional. So I think we got a few more techniques. So I'll keep kind of driving the slides here for you, Adam. This is another technique that you wanted to go over, 1152.
Yeah, 1152. Good old 1152. Launchctl. So Launchctl is it's an interface between macOS and the launchd process. So essentially, it's there kind of keeping launch daemons in other software that needs to be persistent running, which is fun as an attacker, because now you can put some code in there that will keep running even if you kill it. So even like one of the examples that we have on the Atomic Red Team site is just popping calculator, and you'll see that I think on the next slide if you want to flip to that one, Casey.
Yep, got it.
So yeah, so it's a very simple one line. You don't need admin. You can run this as a normal user. The fun thing is you can actually kill that calculator process, and it will just come back. So it will just pop up over and over and over again. And it's a very simple one line just to kind of keep your software running. It's also a good thing if you have any kind of like application whitelisting or some kind of defense software that's preventing certain executables from running, but they might let Launchctl run anything it wants to because that's its job. So this is a great way to kind of subvert, go around some of those defenses, and execute software even when you have really good prevention in place.
Gotcha.
So with something like Launchctl, I know we're just saying calculator on here, like what would be, so like for like Atomic, being that we want to like change this up, like what would be another, like something else that you could do that might be more suspect, like execute a PowerShell script, not PowerShell, but Python script or shell script. Yeah, you could do PowerShell now. Yeah. What else, how much further would you take this, right? Would be like someone else wanted to test it, hey, we could detect calculator, but now I want to take that to the next level. What else can I do?
Absolutely, yeah. So if you look at the command there, everything after the dash is an invocation of an application. And then after that, you can actually put arguments in. So in this case, it's just popping the calculator.app. But you could also call Python and then point to a Python script that does the evil that you want to do. In fact, there's actually an example of that, I believe, on the next slide, if I'm not mistaken.
Or coming up.
Nope. So this is still the calculator example. The next slide after that's got the Python call. This is actually I wanted to call this one out because this is the output of SuperAudit for using the default view. You can also export in JSON if that's easier for your other systems to consume. But this is just kind of an example of if you were using SuperAudit, how you might find something like this. You can see the execution of Launchctl. You can see the full command line. You can see the POSIX spawn of the child process. So just kind of a good way to grab onto that. You could look for Launchctl and submit. If you just look for Launchctl, you're going to see a lot of stuff. That's potentially very noisy just because of all the stuff that's running on your system and needs to launch up at start time. But submit is something that happens infrequently from my experience. So actually adding new things to the list of launch daemons and software that needs to persist.
Awesome. Yeah, I think we've got a demo that you wanted to show, Adam.
Yeah.
Let me cue this up and I'll let you kind of speak to it here. Give me just a second to
absolutely
tee that up. Cool. There you go.
All right. So forgive the choppy typing of this one. It'll take a second, but essentially, I mentioned that you can really run any kind of software that you want after this, after the double dash. So in this case, what I'm going to do is I'm going to run a Python script. So in this case, I just name the process evil Python, and then I call. So I'm calling the Python script directly. And then what you're going to see is in this case, I just made a little box pop up that says Python code is executing on your machine. And it's a nice little way to say, okay, it's executing. You'll notice I don't execute it again, but it pops right back up. So it's in most cases, adversaries are not going to give you a pop-up box that tells you what's running on your system. But imagine if you had a Python script that was, that was killing your security tools and was collecting information and staging files for exfiltration. That stuff's very common, and it would all be running behind the scenes without your knowledge. So that's a great use case for how you can take something, in Atomic that's relatively safe, like popping calc, and you can turn it into something that is really, really nasty and really scare your blue team.
Awesome. Cool. All right. So yeah, as we go through this, if you guys may have questions, feel free to drop them in the chat. We'll address these once we're done. We've got a lot of material to get through, so I want to make sure, at least if you do have questions on anything we're showing, you drop those in. So we've got another technique that Adam's going to take you through, which is about input prompts. So technique 1141 if you're tracking against the MITRE matrix. So take it away.
Yeah. Yeah, so this is another example of AppleScript, and in this case, this is an unprivileged user that has ability to run AppleScript from the prompt, and what it's able to do is actually pop up nice little dialog boxes. So if you've used tools on the Windows side, there are corollaries there where you can pop up a box for a user, get them to type in their password, it comes back to you, you're happy, you have all the access. But you can do the same thing with AppleScript as an unprivileged user. So if you land on a system, you don't have any privileges, but there's a user that's sitting down at their keyboard, you can use something like AppleScript to pop up a box and get them to hand you their password, because users love typing things into boxes. It's part of their nature. So we can actually jump to the next one.
Yeah,
have an example.
Yep.
So this is the actual command line, and on the slide after this one, I'll give the full command line. But shout out to Fuzzy Knot, because we got this one from his blog. It's a nice local phishing technique. So if you want to skip on to the next one, Casey.
Yeah, sure. Yep, there you go.
So this is what the command looks like, and basically it's telling the system preferences application to activate, and then pop up a box that says software update, we need your password. So as a user, that's a very convincing looking box. It looks just like all the other boxes Apple pops up to you. So to them it's like, oh well, IT probably pushed down some software and I need to put my password in here and make it work. What you'll notice, or what I found in a lot of organizations, is a lot of people that have MacBooks just end up with admin rights magically, because they're harder to manage, and so you just give people admin rights and let them go and do their thing. So this is a very quick way to escalate your privilege all the way up to root, especially if they're already in the admin group.
Yeah, I've actually seen this one, Adam, with like a 1Pass or a password manager. So you could tell the password manager to pop a box.
Oh yeah.
Like 1Pass or something like that, so that then they're prompted, and then you get all the credentials. So yeah, this is definitely something that's been happening. So yeah,
absolutely. Yeah. So you can, where that says tell app system preferences, you can tell various applications on macOS to launch, and you can really get a lot of you get really creative with it and make some really convincing campaigns.
I think one of the other examples we have, or we've seen, is with like iTunes, right? The iTunes dialog box, enter your credentials to log in.
Oh yeah.
Steal their iCloud password. Yeah, then you can do all kinds of stuff.
Is there any way to prevent that? I mean, is there any way to say, look, AppleScript, like you can't prompt these apps? I don't know. I'm just asking if there's a way to mitigate this, or.
There's some built-in controls. So AppleScript has the ability to beep the system and talk out loud and do a lot of other things. Really get into the nitty-gritty of the operating system.
Can you eject the CD-ROM as well?
Yeah. Where? Can you make all the dongles fly out the side of it? Is that what you?
Yeah, exactly.
There's a lot you can do, but some of that's gated behind some permissions where you have to say AppleScript's allowed to interface with these subsystems. And again, restricting to authorized signed code will save you a lot of heartache.
Got it. That
with
makes
some
sense.
of these techniques.
Cool.
Yeah. So
All
we
right.
can get to the next one. I think it's
Yep. Keep rolling
second
through.
part of
This is this is sort of the telemetry from that. Yep.
just a way that you could kind of grab this test and grab some pieces of it out to make some detection capability. So in this case, you know, you can look for the process name of OSAScript. As I mentioned, it shouldn't be running a whole lot in your environment. You should be able to tune out the false positives relatively quickly. But you could also say, hey, I'm looking for system preferences in the command line or the word password. If OSAScript ever has anything in their command line that says password, like that's probably weird. Maybe it probably shouldn't be asking for passwords. So, and that's just, you know, there's just kind of like a little example of what the telemetry might look like in Carbon Black down there at the bottom.
Cool. Awesome. I think similar.
Yep. So this is actually using the eggshell surveillance post-exploit kit. You can call the same type of pop-up box with AppleScript, but you run it all from like a shell command, and just say, hey, this is going to be an AppleScript type execution here. So you can do the same thing. So if all you were looking for is OSAScript, you might potentially miss it. So this is just kind of an example of make sure that you're testing things in different ways and make sure that your detection capabilities can find it.
Is that open source? Eggshell, is that a free like post-exploitation tool? Okay.
Yeah, it's out on GitHub. It's got a lot of fun stuff you can do with it aside from, this is just kind of how it escalates privilege, but it has some persistence mechanisms. It's got some ways to try to get passwords out of Firefox, steal your Facebook cookie, which is an interesting fun one. You know, if you wanted to try to steal somebody's real life. You know, there's a lot of tools for you know, in that toolkit for turning on microphone, turning on camera, recording input at the keyboard. So it's very full featured, but very focused on surveillance. So
gotcha.
Use it for good, not evil. People out there in the webinar land.
Awesome. So I guess we were kind of switching gears a little bit. We've got a couple of Linux techniques we wanted to cover. Those are some of the Mac ones, but I'll let you guys speak to these as well.
Yeah, so this is one of the ones from the Linux side, disabling security tools. This is a good point to kind of mention that because there's a lot of shared systems between Mac and Linux, like Bash and Python and a lot of these things, a lot of these techniques you can move between the two platforms. It's just one of those things. If you're working on something, it's very Bash heavy. You know, the technique is Bash or Python heavy, or you know, uses some of these Unix type binaries. You can probably pull them off on both systems. So don't feel restricted just because it's in the Mac matrix and not the Linux matrix.
Gotcha.
So in this case, this is just disabling security tools. So this is actually something that can be very, very noisy because of the fact that it's something admins will do. You know, first thing admin does when he can't get his application to work, let's turn off the firewall, you know, let's turn off logging, let's turn off all the security tools because they're just hurting us. So obviously that's terrible, but it's something that we have to deal with, right? So there's nothing particularly sexy about these techniques, but they are very useful at subverting detection and you know, you're alerting your team that something's happened. So turning off the firewall, now all of a sudden you can do all kinds of things. So when you're building detection capabilities for these types of things, you just want to be looking for, you know, did somebody turn this off and not turn it back on? You know, and maybe that's something that is better as a daily review of your configuration rather than a real-time alert. So just play with it, see what you can get away with.
Cool. So I think we've got a couple techniques for persistence. Oh, go ahead. Sorry, Mike.
No, I was just gonna make a random comment about systemctl back there and just like how powerful that is. You know, just from like a monitoring perspective between like check config, systemctl, you know, it can get very noisy with those things, but it's always interesting, like, you know, someone turning off the web service or disabling other parts on a Linux box or whatnot. It's just different, you know. You can get very noisy quick.
Looking for that and trying to baseline like how, like which users use systemctl, which system that's used on or whatever. Makes sense.
Yeah, and looking for things that are stopped versus things that are disabled. You know, definitely those disabling something definitely has more weight to it. you probably want to see that in a more real time, just because somebody's turned something off forever. You want to make sure that it's a service that you didn't care about.
Makes sense. Awesome. All right, so some persistence techniques in the Mac and Linux environments.
Yeah, so these are both using both using Bash, both using typical Unix type systems. So these are just ways that scripts or adversaries can persist on your systems. There's a lot of research and a lot of people know all the common Windows persistence mechanisms, but might not necessarily know what to look for when they get into Mac and Linux systems. So these are pretty straightforward. On the left side, we've got 1156, which is hiding in the Bash profile in Bash RC. So very simple one-line script to just push a Python script into your profile. So every time you're logging onto a box or opening a shell, you're potentially running this script. So that's kind of the effect there. And a lot of people don't mess with their profiles. A lot of people don't even know that they have a Bash profile, when they're logging in or they're running the terminal. So they wouldn't necessarily think to look there. So these are just looking for people manipulating these profiles directly, rather than something that might happen as part of a system process.
Gotcha.
And then on the right side, cron job. So just echoing a very simple line into an object, and then passing that to your cron tab. So just a very simple way to execute a shell script over and over and over again. And one thing that's kind of difficult about those is every user has their own cron tab. So every user has their own set of scheduled jobs. So you can log on as root, you look at your cron tab, you say, oh, there's nothing in here, so I'm not really worried about it. But just remember that there's a cron tab for every single user on the system. And so if you have suspicion that something's persisting out of one of those cron tabs, then you have to go and look at each one individually, or try to catch them as they're being added. Looking for every cron job being added to a Unix-based system might be noisy in your environment. So you'll want to learn who are the approved admins, what are the approved service accounts that are allowed to make modifications to those, and kind of keep track of them.
Has anybody, outside of the MITRE persistence techniques, like one of the tools we would use in Windows would be like auto runs. Is there a good resource or reference we can provide people? Obviously MITRE's done a good job of taxonomy for persistence, but is there any tool to be like, hey, here's your persistence mechanisms in these operating systems? That there may not be. I'm just curious.
Yeah, no, that's a good question. So Patrick Wardle actually has a tool called Knock Knock on the Mac side, and that looks at all of the launch daemons on the Mac side. So yeah, there's definitely tooling out there. There's probably some stuff that's equivalent on the Linux side. And cool thing is it wouldn't take much to write a quick script that would run through each one of, because all the cron tabs exist in the same place on the system. So you could write a quick script that ran through those and built a baseline.
Awesome.
Yeah.
Cool.
I think so. Yeah, like to the cron piece, like it's hard like to detect things being added if they just do cron tab -e, right? Like you don't know what's in the file. And I think that's the part where like OS query comes into play, to where you're able to go through baseline everyone's cron, see what's everybody has in there, pull it all out, understand where's all the evils being placed and whatnot. And I think that's, I personally think that's one of the more powerful pieces of OS query from that perspective.
Totally agree.
Same probably with your Bash profile and Bash RC.
Awesome.
Yeah.
And it's also a good point to talk about like configuration enforcement. So if you have systems that are critical, and you can say, hey, this is what the cron tab looks like on these boxes, you can enforce it. So even if some adversary comes in and makes changes, you're just going to flip it back.
Got it.
Nice. Yeah, that's a solid point for like if you're running like Vagrant or Puppet across your fleet, right? Keeping cron and whatnot like the same, because like your end users can run cron tab -e, edit it, add something evil, or a bad guy can do it, right? And add something evil, and then just move on from there. Yeah, those are tricky things and noisy.
Nice.
Definitely noisy.
Okay, here's another persistence mechanism.
This one was put in there exclusively because it had a good Star Wars meme to go along with it. So this is actually kind of a fun one. this is the trap process, and this was so this is actually contributed by another member of our team, Tony. So shout out to Tony. So trap, what trap does is it creates like a bear trap. So saying, hey, I want you to run this command whenever the following interrupt condition happens. So in this case, we're looking for the exit interrupt condition. So you can put this curl. So what this is doing is it's pulling down a shell script from the Atomic Red Team GitHub, and then it's echoing it to bash to execute it. And it's looking for an exit. So basically what happens is you put this in there, and then it's waiting for the shell to exit. So you exit the shell, and then this is going to get executed. You can also do the same thing with other interrupts like Control-C, just kind of making it really an interesting mechanism to persist with. But like
Awesome.
I said, it's really here because it has a sweet meme to go along with it.
Perfect. Well done.
From a detection point of view, I guess how often is trap used? And like I was just thinking, like you could probably do this with wget and something else in here too. Like how noisy is trap?
You could, yeah. So and it's going to vary by environment, because there's going to be certain tools and certain admins that, you know, they have their own set of tools that they like to use. So definitely, you know, if somebody wanted to run something every time they close the script, this might be something that they would execute as part of like their profile. You know, just whenever I exit my terminal, I want it to do this cleanup script or something like that. So it's just like anything else. It just warrants kind of hunting through your environment, understanding like how often this thing occurs and what you can get away with. So you can tuning is all part of the detection building process. So build something loud, and then, you know, start scaling back, you know, pruning out the known good until you have something where every time it pops up, you say, that could be interesting. That instance of trap looks really sketchy.
Right. Can you append, like, could you have multiple events associated with an exit, or is it like a one, you know what I mean? Like, is the binding like one trap event per exit? Does that make sense? Like,
yeah, no, so I don't know, to be honest with you.
Okay,
I imagine that you'd be able to run several, because they'd all just kind of be hanging out waiting
so
for
you
an
could
exit.
have like an array of tasks or the things. So
Yeah.
they could maybe append something that we should follow up. That's a good question. That makes sense.
That's a great question.
Yeah, that's cool.
We'll test it.
Awesome. Like that.
Download the shell script to make more traps.
Yes,
Yeah,
that's right.
Yeah. I would
Trap all the things.
think trap or anything like that, like calling out to a like even probably raw.githubusercontent.com makes a pretty good indicator that's
Anything that ever talks to raw.github user content is probably
Actually, how you go for catching sub T.
Yeah. Awesome. So those are some of our tests. You know, kind of want to shift gears a little bit. Like I said, we'll have some questions probably in a little bit here that may come up, but kind of to Adam's meme here that he had. Make sure you're testing, right? There's a lot of moving parts for these collection and analysis, so that's why we wrote the Atomic Red Team tests, and everyone that's contributed, we really thank you for giving us those tests. So I think we kind of want to go into shifting gears onto some chain reactions. So I'll let you kind of run with this one, Adam or Mike, talking about like the origin of chain reactions and why we think they're important.
Yeah, cool. Thanks, man. So probably one of the more interesting things that we started doing with Atomic was, you know, on the Windows side, we have, you know, just batch scripts and PowerShell scripts that we could easily just allow people to take different pieces of the techniques on the matrix and just kind of line them all up. And from there, you just execute your batch or PS1, and it does all the pieces that you want it to do. So, so like on the next shot, actually, Case, if you want to drop down one, the idea was we would create artifacts, which you'll find on the GitHub repo. Under artifacts is all the chain reactions. And so like in this particular case, you want to perform some type of system discovery, find the system owners or different users on the box, perform some type of credential access or lateral movement, and, you know, persistence collection exfil. All of this executed with that one-time script generates lots of different like telemetry trails out there within your environment. You're now looking for network data, endpoint data, what's happening on my boxes. Did my endpoint tool detect this? Do I have detection for it? Did our network tool down or prevent or even detect the download of Mimikatz coming into my environment? And then that's kind of the quick point of chain reactions, to be able to execute a bunch, see what happened, go back, see if that telemetry has been found, detected or not, and then begin to tune and or begin to build out the detection within your environment. And so fortunately, with Mac and Linux, we have a couple chain reactions, and Adam's here to walk us through one that he had made a little while back.
Yeah, so this is a chain reaction we call Ranger, and basically its job is to stage the reconnaissance and kind of staging collection portions of the attack matrix. So looking at what kind of software is running on this box, what kind of firewall rules are there, what kind of security tools might they have, what kind of users are there, what groups are they in, all the things that the adversary would care about. So you land on a box, you want to know who you are and what you have. So you start looking around, start looking at what you can get away with on this system. So this is just kind of a note where you can find it in the Atomic Red team. Definitely read the disclaimer, like don't run things from repos you don't control, and don't run things in your environment you don't know what they are, because Casey, Mike, these guys write lots of evil, so you want to know what kind of evil you're going to unleash.
Just run base 64 encoded blobs, don't ask questions. It's totally legit.
Yes, run these things,
always say
don't ask.
Yeah.
But
here's the slide that has kind of your code, Adam, for this.
Yeah, so one thing you'll notice about my code is that it's like Frankenstein. It's hideous, but it does work. So it's definitely feel free to fix it, make it prettier, add stuff to it. So in this case, Ranger is platform aware, so it will determine whether or not it's on a Mac or if it's on a Linux system, and it will run the appropriate commands for where it is. So some of the things just kind of in the screenshot there, so you can kind of see the group information that's being dumped out. It's looking for the user that it has, the groups they're in. It tries to see if it's in the sudoers group at one point. It'll try to grab stuff out of etc password. It does a lot of really a lot of things that common adversary tactics to understand users and groups on the system. Does some looking for running security processes, so looking for in this case looking for Carbon Black, looking for Little Snitch, OpenDNS, some of the things that could alert the IT team or the SOC in the organization that they're on the box. So they want to know what's running there so that they can, before they start executing any code, bringing down any additional binaries. And then towards the bottom, it gets a little more interesting. So it takes all those files that it's kind of staged in a hidden directory. It zips them up and encrypts the tar file, and then it splits it into a bunch of really small pieces. And what you'll see a lot, if you go out and look at attack and look at the different groups, they're looking for ways so they can exfiltrate data that will not alert you. So if you send out one huge file, there's a chance that something might catch it. But if you set up a C2 using DNS, so DNS like packets, and then you just send these little pieces of it out one at a time, you can escape a lot of those measures. So it doesn't take very much at all to take this script and actually add a second box and stand up netcat on it and then just pass all this stuff over to it. So now you're not only testing your endpoints, you're testing your network. Like, do you have any network controls that would see this if you were trying to exfiltrate?
Yep. And you mentioned something really, actually, Adam, in this too, like the MITRE attack has a group tab, and it actually has capabilities of different groups that they've tracked. So if you're not sure where to start, those are good places to go get lists of commands or tools that those teams use, like you've pulled together here. So that's really good stuff.
Absolutely.
Yeah, this is great.
So here's what Ranger looks like. Well, you guys kind of talk about what it looks like as far as telemetry collection.
Yeah. Mike, you want to talk about that one?
I keep looking at Nano. That's all I see on this. Just kidding.
Yeah, works, I mean, don't be a violent.
It gets the job done. Yeah, I mean, from a detection perspective, there's a lot happening here, and you know, and I mean, there's a lot of commands being executed there. I see sudo cat last. I mean, all those command lines, it's rich of information for helping build out detection capabilities for Mac and Linux. And I'll admit, like, building Mac and Linux detection, it gets tricky and very hard. It's either you consume everything and you're looking at everything super broad all day long, you know, and or having like super tight and concise, like specific detectors for some type of behavior, malware based behavior. It gets messy. And I mean, from Carbon Black, you can just see shell everything, just spawn all the things. I mean, part of it looks like admin activity, right? Like sudo cat grep, it's all normal day-to-day stuff. I got ps in there, who am I, you know, and that's the hardest part. And that's what I love about like the Linux Mac, like this Ranger chain reaction in particular. It's just normal looking in a way, you know. It's cool.
Awesome. Yeah. All right. Well, we're gonna have some time for some questions, so this is gonna be good. We wanted to make sure we pointed out where you can get the Atomic Red Team from our GitHub repo, and we would love to have additional contributions. We've had some good feedback. Lee Holmes recently helped us with some automation for Windows PowerShell, so wanted to give a huge thanks to Lee on the Windows side. Also, we are working on some automation using YAML, so that should be coming soon. So some people have asked for some more standard templates and ways to consume Atomic, so we've heard that feedback, and we want to provide that to you guys. So if you have feedback for us on ways that would be good to format that, let us know, because we're in the process of building that out this quarter. So I think with that, unless Adam or Mike, if you have anything else you want to add or touch on, I think we're at a spot where we could do some questions.
Yeah.
Thanks everyone for your time. We'll see if Kia's got some questions queued up for us, and we can dive right in. So.
Yeah, thanks. There are some questions. Is there a macOS tool equivalent that gives execution history like Sysmon for Windows?
Yeah. So you could use OS query for that. That'll give you one of the queries you could do is just looking for all processes and schedule that at a regular interval, looking for process execution. Super Audit is another one that's going to give you that level of detail on macOS. It takes a little bit of playing with. So specifically Super Audit, you can use different filters. So you can just look at like network connections, files that are modified, processes that start. Each one of those is its own filter. So you could actually run it multiple times, output to a file, and then consume that. So yeah, you can definitely use those tools to get a Sysmon equivalent of that type of data.
Cool. Here's another question. Do you guys have chains that link together real-world exploit/malware scenarios? The problem in testing, in the testing space, is that we rarely replicate how people really get infected.
We don't. Well, that's a good question. We don't put any malware samples into the Atomic repo, and specifically there are some techniques in the pre-attack that describe like initial access. I guess the one thing we have, for example, in Atomic would be like on the Windows space, we have like a macro download that you could use. But generally, we've tried to steer clear of specific malware samples. Just we don't want to be in the game of distributing those and hosting those in our repo. But if you have some specific examples or something you'd like to see that maybe we could add, I would suggest maybe submitting a pull request to Atomic, and we could take a look at it, because we certainly know we missed some things, and we're open to that kind of feedback. So if there's a technique that you've seen or would like described into a unit test that we could do in Atomic, by all means, let us know what that might be. I'm not sure if that answers the question, but hopefully that gives you some insight. We don't really want to put malware into Atomic.
I was gonna say the same. I think it's under artifacts. It's Dragon's Tail. That's what we call it, and it's modeled after Group 50 from MITRE. I think it's like APT32. But yeah, it was there's a blog post for that guy, and it shows how to embed that macro in a Word doc and whatnot, and kind of simulate from that. Yeah. And that's kind of the whole purpose of Atomic, is having this small unit test where like you can go more advanced as you want to take it, right? All the building blocks are there. It's just now embedding that base 64 into something that you want to execute and follow a similar pattern. And yeah, I mean, I would love to have more chain reactions that did a little bit more like that too. That'd be super sweet.
Awesome. Good questions. If we don't get to all the questions, typically what we've done in the past is a blog post that addresses questions that were asked that we may not get time to get to. So appreciate the feedback on that. So
here's another question. When is MS Build porting to Mac?
It's a great question.
That's definitely a troll question. Yeah, MS Build, it's I don't know. PowerShell's on Mac, so certainly we recommend a lot of adversaries to go ahead and download PowerShell to the operating system and then port your PowerShell tradecraft over.
So what you do is you poison Casey's DNS, so TechNet reroutes to developer.apple.com. It'll just happen. It'll spontaneously come out.
That's amazing. So fun. Good times. Any other questions? I think we're closing in on our hour, so I want to make sure we respect your time for everybody. So I'm not sure if there's any last questions. Otherwise, we can kind of wrap it up. Again, reminder, we will have a public version of this, and we'll post the recording, so you'll have that available, and we'll post the slides and any additional references too. So I'm not sure if there's no more questions, Kia, I think we can wrap it up.
We've covered all the questions. Thanks, guys.
Okay, great. Thanks everybody for your time. We really appreciate it. Please provide us feedback if this has been helpful, so that we can always improve. So thanks for taking the hour to spend with us and give us some feedback. You've got our Twitter handles on the screen there. You also can go out to atomicredteam.com to get additional resources. So thanks everybody.
Awesome. Thank you guys. Appreciate it. Thank you everybody.